Hi, welcome back to Chat by the Fireside Series 3. This is Bindu. In our last two sessions, we looked at how to arrive at a good research topic and how to formulate your research question. It's been a while since I did my last session, so I'm kind of excited to be back, and thank you for your patience. Today's session, we will be looking at how to formulate a good methodology. Now, I've said this in my last session that research question is extremely important element of extended essay, and therefore you need to spend a considerable amount of time in identifying a good research question. Now, research question provides direction, it shapes the investigation, and it also influences every decision that follows. So it definitely is one of the most important elements of the extended essay. But methodology is also equally important. So what is methodology? Methodology actually provides a roadmap or outlines exactly how the research is going to be conducted. So if research question tells you where you are going, the methodology tells you exactly how you will get there. Now, there are different kinds of methodologies. There is experimental investigations, surveys and questionnaires, there's case studies, and there is field investigation, right? But we know that, and more, right? But we know that if all of this put together can be broadly be divided into two kinds of research approaches for methodology. One which is called the qualitative method research approach, and the other which is called the quantitative research approach. Now, the quantitative research approach is where you generate numerical data, and there's a scope for statistical analysis. So surveys, experimental investigation, and field investigations are considered to be a quantitative research approach. Whereas qualitative research approach is, interviews and observational studies and case studies are all qualitative. There is no number crunching, there's no numerical data that you generate, but you provide, there's a rich, detailed understanding of the concept, right? Yeah. So, but when it comes to sciences, right, whether it's physics, chemistry, biology, or biology, these three sciences, a quantitative approach is more preferred over than a qualitative approach. Now, why is quantitative approach preferred? Research approach preferred is because it's objective, it's measurable, and it's reproducible, right? There's scope to do a statistical analysis. There is a much more reliability. Now, the reliability comes from the fact that there's objective measurements. That is, we are talking about. There's a standardized procedure, right? The scope for error is minimum, so those kind of things. So there's much more reliability, and of course replicability, the fact that you can do it over and over again and produce the same outcome. There are less biases in this because we are not looking at a personal opinion here, but it's basically certain numerical data, which is what is used to understand be able to answer the research question. It also allows you to evaluate the reliability and validity of the results by stating the uncertainty. So there are some very, definitive advantages, but there are also disadvantages. It can be time consuming. There are requirements of tools and procedures and apparatus which one needs to be comfortable using, right? So there are those things, right? It can get extremely tedious, it's a long-term thing. Yeah, so there are some disadvantages as well. When it comes to the qualitative research approach, it has got a place for itself. Now, qualitative approach is, as I said, that's you're not generating any numerical data, but it's more descriptive information that we're looking at here. In biology, there is, generally for sciences, we do not use qualitative research approach as a standalone thing, but in research biology we use a qualitative research approach in, say, ecology, or could be possibility in gene sequencing. If you look at gene sequencing, where you're doing data mining and homology searches, this does not use numerical value. All right, or animal behavioral studies, animal behavior and human behavior may not be using numerical data. But when it comes to extended essay in biology, we prefer that it is more quantitative. As I said, those advantages which I just listed some time back, and qualitative data can be used to support the quantitative information. Sometimes the numerical data may not be able to give you the information that visual observation can. So therefore, qualitative information can be useful in supporting your overall understanding of the result. But when it comes to ESS, you could use a qualitative research approach as a standalone one, right? Case study based, you could make it completely interview based or a case study based approach, right? And you could also use a mix of both, or it could be just quantitative alone, right? See, the advantage is that there is no, what you're getting is, rich, detailed information, descriptive information, which is sometimes be extremely useful. It also captures information that cannot be expressed numerically. To study complex phenomena, sometimes numerical values may not be able to, data may not be able to explain those complex phenomena, right? The limitation is that it's subjective, cannot use statistical analysis, requires careful documentation of information to reduce biases, because unlike the numerical data, you can't weed out biases that easily, and also you cannot generalize. In biology and in maths, we can generalize certain trends and patterns that we see, or a relationship that you establish can be generalized, but we cannot do that in case of a qualitative data because of the subjectivity. Yeah. Now, what are the elements of a good research methodology? So I'm going to list down some important elements of a good methodology, and so you could possibly keep those in your mind. So number one, the methodology should clearly align with the objective of your study, and it should be able to answer the research question that you have stated. So what kind of an approach that whether you'll take a qualitative approach or a quantitative approach or a mixed approach, it's all depend on what your research question is and how well would you be able to answer that research question. Say, for example, if I'm just taking a couple of examples here to sort of understand what kind of an approach would you be using. Okay, so for example, in biology, my question is, to what extent does chronic exposure to artificial light at night affect circadian rhythm and activity of Drosophila melanogaster? Now, a question like this, I would obviously be using a quantitative method, because I would have to generate some numerical data in some form to establish this relationship between prolonged light exposure and circadian rhythm, right? So I would have to probably look at the number of movements that the organism has taken in a given time, and we probably would have to look at the number of times the organism has rested, the number of activities that the organism has taken, or maybe even to look at the duration between the activity and the resting time. Similarly, there's another example, and this time I'm taking an example for ESS, and that would be, say, for example, to what extent does fast fashion model drive overconsumption and environmental sustainability? Now, to answer this question, I could use a bounded system, right? Case study is basically a bounded system, right? Which gives me an in-depth understanding of through using that bounded system, I can try and understand this relationship, right? So I could use a company, right? A fast fashion company and get information regarding that company from company reports to environmental assessment reports or any other articles from of the company, and or consumer behavior, so all kind of data that I could gather. I could extract some quantitative data if required, or I could just present it as just a qualitative highly sort of descriptive information, but I presented it in the form of a case study here. I've actually taken a real-time company to understand this relationship, so it can be purely case study based. All right, so that this is how you identify your methodology should align with the objective of the study or the research question. Now, the second element is identifying sampling and identifying the target population. In sciences, by the time you actually do state the research question, you would have most probably identified the sample, right? And because you would have already done some literature review and identified the sample. Now, if you have not done that, then of course literature, you can go back to the literature review and understand what sample would be ideally be suited for the kind of work that you're doing. What would be your target population? In this case of it's a population study. What age group do you need to consider? What kind of, is it going to be gender specific, right? And if you choose to do that, if you're using a target population or a particular sample of, say, for example, I'm using a plant sample or a Drosophila melanogaster, as I said in the earlier research question, I need to clearly justify why you have used that sample or that target population. How do you think that is best suited for the study? So I think justification is a very, very important thing, justifying the methodology, justifying the sample, justifying the variables, and that needs to be documented as well. IB prefers it. IB want to know whether it's just how did you come about how did you identify the variable and why that variable is best suited for the kind of work that you're doing. The third element is tools and technique, right? The technique of gathering the evidence, right? Which is an important element. You need to use a clear technique. It could be a standardized procedure, but what tool and techniques are you going to use? And again, justification. As I said, justification is an important aspect. It has to come all along as to why you chose a particular technique. So what you need to understand is the technique should be able to allow you to gather enough data. And in biology, we need 5 treatments and 5 replications, right? So the technique should be able to should include 5 treatments and 5 replications, because that allows you to do the statistical analysis. Say, for example, if I'm doing the effect of salinity on germination, I need to have 5 salt concentrations, and I'm going to look at the number of germinated seeds. That's my dependent variable. Now, the reason for why in biology we use 5 treatments and 5 replication is because our samples are highly variable, right? Unlike in physics and chemistry, where the objective measurements that they do not have such variability, right? They generally are measuring time or distance or things of that nature, which are highly objective measurements, very defined measurements. There is no possibility for such a, for example, if I'm looking at germinating seeds, the number of seeds germinated, apart from salinity, there are other factors affecting germination of seeds. The viability of the seeds and the composition of the seeds. So there are so many other factors. So there's a high chance there's more variability, and therefore to weed out that variability, we need to use more number of replications. And a 5 treatment is considered ideal, because that allows you to see the whole spectrum. And statistical analysis also becomes extremely important in biology because of the same reason. Because statistical analysis allow us to know whether the results are due to the observed differences that you see is due to the treatment, or is it due to other reasons, right? How true is your mean, that you have generated. So basically it allows you to know whether that difference that you see, is there a significant difference between the observed and the expected result, right? Or the difference that you see, is it because of the treatment that you have administered, or is it because of other reasons? So whereas in physics and chemistry, well, because there is no variability, the experimental errors are largely systemic errors. It's not other random errors are very, very few. Such kind of statistical analysis is not required. Yeah. Other important element of a good element of a good research methodology is validity, reliability, and ethics, right? Now they become the validity can be ascertained by choosing the appropriate dependent variable. That is one of the important things to validate your the methodology. Control confounding variables. I know there could be many. We'll try and you have to try and control as many confounding variables as you can. Use calibrated instruments. Follow standardized procedure. IV range chosen is appropriate. So if you keep all of this in mind, you have validated your methodology. There is a validity to your methodology. Reliability is the reproducibility. How do you know that this is reliable method, or is you can do generally we do a pre-lab study to know the reproducibility and reliability of the procedure, right? So that can it give the same, would it yield the same results when it is repeated? And of course ethics, right? The ethical concerns should be clearly be identified. The safety and ethical concerns should be clearly known, and it should be under the the experimental policies and all of the policies of scientific research. Extended essay in sciences should be kept in mind while you are formulating the methodology, right? And the other important element of a good methodology is identifying the strengths and limitations. I think you should know the strengths and limitation of the methodology right at the beginning. You should know what are the strengths and weaknesses. Generally, this is something that you always look at it right at the end when you have to do the evaluation, but you have to do it right at the onset when you have formulated. What are the strengths of this thing? What are the limitations? Because if there are limitations, then can those limitations be mitigated? Or it can be reduced greatly, because some of these are not looked at, and when you look at the end, when you realize that there's been so many errors and limitations of the experiments, and you can't do little about it. So it is to be understood, and sometimes if the limitations are far too many, it's the entire study becomes null and void. So it's very important that you understand whether those limitations are not going to be a stumbling block in being able to answer those research questions, and how can you take care of them in your methodology, right? It's an important aspect. It's an important element of a good methodology. So that you have to identify the strengths and weaknesses, whether the sample size is sufficient, right? Whether the range that you've chosen is whether you have taken care of all the confounding and variables, right? I'm not saying that everything can be taken care of, but it should not be a case where you're looking at the end and you see that the errors are just far too many, and that would impact the results. So you should be able to take care of them right at the beginning. Now, the quantitative research approach could be done using two kinds of data: the primary data and the secondary data. Now, I thought this discussion was important because for a very long time, people used to shy away from using secondary data simply because they felt that did not, it was not very well scoring for various reasons. And so therefore they should shy away from using secondary data. But what I've seen is that over the last few years, we have seen that there are some secondary data can also be used and to do a good extended essay, which has also gone on to score very, very well. So I think it was very important to have this discussion, and so therefore I've included this element in my session today. Now, what is primary data? We all know what the primary data is. It's a set of data that is collected directly by the researcher, right? When you go on to do an experimental investigation and generate some data out of it, that becomes a primary data. Say, for example, measuring growth or counting the heart rate in Daphnia or a quadrat sampling. So in biology, these all are actually can generate primary data. In ESS, any kind of biodiversity measurements, can be a direct primary data. Measuring the pH of soil, say, it's another example. Now, so what are the advantages of primary data? Is that the data that you're generating is highly, highly specific to the research question. There's a greater control over the variables. You can develop lab skills. It allows evaluation of the experimental limitations, and especially when you're writing down those limitations at the end, it is very, very clear to you what those limitations are, which seems like one of the biggest drawbacks when you are doing a secondary data, right? Because it's actually data collected from various sources, and you're not very, it becomes very difficult to understand those limitations. Yeah. The disadvantage is that you need necessary tools and technique to be able to generate the data. It could be extremely time consuming. There are ethical and safety concerns while generating the primary data, and you're restricted. So that there is only so much sample that you can use, because it's to be done in a given period of time. Now, secondary data is wherein it involves analyzing existing data collected to answer a research question. So you're basically using already existing data to be able to analyze your research question. So it has its certain advantages. It saves time. It enables large-scale studies over an extended period of time. For example, if you want to look at how some things have changed over time, like over 10 years or 20 years, it allows you to do that. There are very little ethical and safety concerns, because you don't really have to not consider that as at all, because it's the data that you have, it's from existing data. It's highly reliable, because most of the data that you are collecting are coming from research articles and government and international organizations. So there are highly reliable set of data. The disadvantage is there's a limited control over the data. You will have to use whatever data that you're able to get. Sometimes it's extremely difficult to even get the data. It may not be a perfect match to the objective of your work. There are possible biases which you might have to bear with. The data quality can also vary, because there are so many different sources that you're using for the data. And as I said, the limitations. One of the biggest drawback of secondary data is to understand the limitations of the work. But that can be found. It could probably is available in the research papers, but many times that information not be readily available. Yeah, so then it gets difficult to understand what the limitations of the work of the study, that the limitations of the study. But what you can look at is the limitations of the data gathering itself, right, rather than the experimental work and its limitations of each of the study that has been used for the purpose of extracting the data. Now let's look at the steps one need to take while collecting secondary data. Number one, would be to start with, as we always do, is to start with identifying the clear objectives of your study. Now, to do that, I'm again going to take an example here, and the example is from ESS, and the RQ is, to what extent has Singapore's water management strategy contributed towards combating long-term water scarcity? So in this question, the major objective of the study is to understand the water management strategy that Singapore has taken, which is called the 4 national taps. They have 4 major water management strategy. One is, of course, their catchment area, which drains the water into major reservoirs, which has a certain capacity. The second is the import water. Certain amount of water, volume of water is imported through the international treaties. The third is what is called the NE water, which is the water which is recycled water, which is recycled through a very complex process of microfiltration and reverse osmosis and a couple of other methods. And then they have the fourth strategy, which is the desalinization. Now, what we're looking at is how these management strategies has had contributed to the meeting the demands of water in the population, and how this is going to prevent water scarcity. So that is the objective of the study. So therefore, the second step towards collecting that data that is specific to this RQ would be to identify the data that you would need to be able to answer this research question. So some of the data that would be needed for this research question would be the overall consumption of water, that is over a period of time, the desalinization capacity, the reservoir capacity that Singapore has, the water demand and its projection for future, the NE water production and capacity. So all of this data, and of course they also need government policies that is related to water supply and water consumption. So these are some of the data that would be required to be able to answer, to meet the objectives of the research question. Now, once you've identified the set of data that you need, the next step would be to find credible sources. So what are those credible sources that you can look out for? You can possibly look out for national databases, government agencies, international organizations, peer-reviewed article, university research papers where you could find some data that is related to the research question that you are trying to work on. So these are some of the credible sources that from where such a data could be collected. You should avoid commercial sites and blogs and articles. You should stay away from those. These are not credible sources. So avoid taking data from any such kind of sites. Once you have identified a credible source, the next step is to evaluate that source. That's a very important step. You need to know, you need to evaluate the source. Number one would be the author, right? Who's the author? Who's the authority? Number two would be the accuracy. The accuracy can be found by what was the method they have used in collecting that data. The relevance of the data, whether it is relevant to your RQ, how close is it to your RQ, how, that needs to be ascertained. Biases, right? It's important to understand if there is any political or commercial biases. For example, if you're taking from some NGO reports, right, there is a possibility of a political bias. So that's something that you need to be identified. And of course, the currency, how current is the data that is available, right? So once you have evaluated it, the next step would be to extract and record this data very systematically, right? So open up a spreadsheet, store the data, upload this data. Along with the when you upload, we also have to record the literature review matrix. That is all kind of information: the author, the publication, the date, time, any information that you can link. All of this information needs to be recorded, right? Then comes the final step, which is to analyze this data. So you need to look at the data carefully, analyze it, understand the trends, patterns, and relationships, gaps that is there, right? All of that needs to be analyzed, and also you need to create, write a short note on that analysis, right? These are important steps, because at the end, when you look at all of the data that you have, you get a bigger picture of where you stand as far as the data that you have collected, and your how that data will be able to address the objective of your study. Okay, so yeah, you have to analyze it, and you also have to evaluate it. So that's the last step. So evaluate is where you're looking at the strength and weaknesses of your data, right? So you got to put that down, so that, as I said, at the end, when you're looking at all of that data together, you understand what is that you have and what you don't have, right? And that then would be able to take you down, then you will be able to generate a good analysis and arrive at a conclusion at the end. Well, we have come to the end of the session, and so my key takeaways from today's session are the following. Methodology should always align with your research objective, right? So if you want a clear, good outcome at the end, the methodology that you adopt is going to play an extremely important role. So therefore, it needs to align very clearly with the objective of your lesson. Choose your methodology because it answers your research question, not because it's an easier methodology. Primary and secondary data both have their strengths and weaknesses, and therefore one is not better than the other. Good research depends on collecting the right evidence and not the most evidence. And now for the parting shot or parting thought. Methodology is the bridge between research question and a credible conclusion. So thank you. Thank you for watching. Like, share, and comment. I have tried to include what I thought was important, in methodology, what I have experienced in my years in teaching. I'm sure there's more to the methodology story, so please come forward and share. My next Chat by the Fireside session is going to be on mathematical tools, and so therefore I see you very soon. So thank you.